Hey class, today we're going to be starting our Data Analysis Statistics chapter. And these notes are going to be pretty in-depth, so you may need to pause the video to write in all the little things. I've already written them in to try to save us some time here. All right, so we're going to jump in and look at some categorical data today. So the 3 rules of data analysis are make a picture, make a picture, make a picture. It's really important that you make a picture. A display of your data will reveal things that you are not likely to see in just a table of numbers. A well-designed display will show important features or patterns, either expected or unexpected in your data. And choosing the most appropriate display is vital to clearly communicate the information. There's a couple different types of display you can choose, and we always want to make sure we try to get the best one for the data set. All right, so categorical variable indicates what group or category each individual or object belongs to. And the data is commonly descriptive responses or responses to questions or yes, no answers. So some of these examples here are like, what are your eye color? You would describe it as blue or brown, or you wouldn't say 7, so it's not numerical. These ones are a little tricky because zip code and area code are numbers. But if you think about it, those numbers aren't measurements of anything. Having an area code or a zip code or area code 916, it's not like 916 things that you counted. It's just a label. So because it's just a label, even though it's numbers, it's actually a categorical variable. All right, and the data have to be counts or percentages of individuals or objects in those defined categories. We use frequency tables to display the counts within each category, and also frequency table can be referred to as a frequency distribution. So make sure you're looking through your notes when you're working on your homework. If they say frequency distribution, it wants you to make one of these tables. Example 1. A college student recorded the origin of manufacture of cars in a campus parking lot and created the frequency distribution below. Explain why the data is categorical in nature and comment about any aspect of the data. So this data is categorical because these numbers, 212, 45, 102, they're counts within each category of car manufacturers. So somebody went around the parking lot and just started counting how many American cars there were and so forth. Commenting can be pretty simple, just something like the most cars are American and the least amount of cars are European. It's just kind of simple if they don't give you any more information than that. All right, let's look at a bar chart. So a bar chart is the first type of graph we're going to look at, and it's the graph we use mostly for categorical data. A bar chart displays the distribution of a categorical variable, showing the counts for each category next to but not touching each other for easy comparison. So things that we want to make sure we do, we want to make sure that we title our graph, and you can put it below your labels on your horizontal axis or above the graph or to the side. I didn't really have much room, so I put it to the side. We always want to label our vertical axis, and in this case, we're going to use frequency. So I'm going to label it as frequency because I'm just going to use those counts. Frequency is just another word for how many are in each category. And then we want to write our categories on the horizontal axis. So I have American, European, and Asian. And then we draw bars. We make sure that they're not touching. There were 212 American cars, so I'm going to draw this up just above 200. European only had 45, so that's like right here. Try to make sure it's roughly the same width as all the bars are roughly the same width. And let's see, there's 102. That's somewhere around here, Asian cars. And there's a bar chart. A relative frequency table displays the percents or proportions rather than the counts in each category relative to the total number of observations. So in order to figure out the relative frequency distribution for the example 1, the first thing we need to do is we need to total the number of cars. So if I add up 212, 45, and 102, I get 359 cars. So then to get the relative frequency for American cars, I would take 212 divided by 359. And then I can write that as a decimal, 0.591, or I can change that to a percentage if I want. I usually just keep them as decimals. All right, and then European, we had 45 cars out of the 359, so that's going to be 0.125 or 12.5%. And 102 out of 359, we end up with 0.284, I think, if I'm reading my writing correctly, or 28.4%. And those percentages should add up to 100%, so you can always double check that you've done it right by adding up your decimals to make sure that that equals 1. Right, now when we create our chart, again, we want to make sure we title it. Every single time you do a chart, you need to make sure that there's a lot of information on that chart. So if anyone's looking at it, they know the categories, but they also know what those categories represent, which is car manufacturer in this case. And then on our vertical axis, we are going to title this relative frequency instead of just frequency. And on our scale is going to be the decimal values. I need to go up to at least 0.6 because that's the highest that I have. So let's see, 0.3, 0.15, and 0.45. You could count by 0.1s if you want, or 0.2s if you want, if that's easier, whatever you need to do. All right, so American cars went almost all the way up to that 60% there. European cars are only at 12.125, so that's pretty far down here. And then Asian cars are up almost at the 30, looks like this. And if you look at the bars and the relationship between those bars, it's identical to the frequency chart that we did before. The only difference is our vertical axis is percentages or decimals instead of the counts. That is the only difference in the two graphs. All right, contingency tables. So a contingency table allows us to look at two different categorical variables simultaneously. Each cell gives the count for a combination of values for the two variables. So for example, now instead of just knowing the car manufacturer, they also have recorded whether the driver was a staff member or a student. And we have that information here. So the first thing we want to do before diving into the math is we want to add up all the totals. So there are 195 total students. There's 164 total staff member cars. And then these totals should be the same as they were before. Oops, my pen is messing up here, sorry. So 212 American cars, 45 European cars, and 102 Asian cars. If I add up all the way down or all the way across, I should get 359 total cars. So this is like the total. All right, so here it says, what is the significance of the cell with a count of 33 in context? So you look for 33 and you say, what does that represent? It means there are 33 students drive European cars. Doesn't have to be super complicated. Just get to the point and make sure you use all the two different categories in there. What percent of all cars surveyed are foreign, given that we are in the US? Given in US. So given that we're in America, foreign cars would be European and Asian cars. So we could take the 45 European cars plus 102 Asian cars out of the total 359 cars, and we get about 40.9%. It did say specifically what percent, so I want to make sure my answer in this case is a percentage. What percent of all cars were driven by a staff member? So there were 164 staff members out of 359 total cars, and that's going to be 45.7%. What percent of students owned American cars? So this one's a little different. What percent of students owned American cars? So my total isn't going to be 359 anymore. It's going to be total students. because I'm only looking at what percent of the students. So my denominator is going to be 195 now. And out of those 195 students, 107 of them have American cars, which makes that 54.9%. And then what percent of the American cars? So again, now the denominator is going to be total American cars. So that's going to be 212 are owned by students. So it's still the same numerator because out of that 212, there's 107 students. But the denominator is different the way it was phrased, and that's going to be 50.5%. So just playing around with the values in our contingency table there for a little bit. All right, so marginal distribution is the frequency of one variable from a contingency table. So it can be expressed as either counts or percentages. I chose to express these as counts or frequency here. So for A, the origin of, so I want the marginal distribution for the origin of car manufacturer. So all I want to do is take this contingency table, which showed me the car manufacturer, but also the type of driver, student or staff. And I want to just simplify the table to only one category. So that's kind of what this is saying to do. So my one category is going to be car manufacturer, which means I'm going to have American cars, European, whoa, my pen is having issues, sorry. European and Asian cars. And then this is actually the same table that we had at the very beginning. B wants a marginal distribution for driver type. So now we're going to simplify that contingency table and only focus on the type of driver. So we have student or staff. So we actually don't see any car manufacturer types here. I had 195 students and I had 164 staff. C is the origin of manufacturer given the condition of staff. So now I want the origin of car manufacturer. So I want American, I want European, and I want Asian here, but I'm doing the frequencies, not the total out of all the cars, but only out of the staff cars. So on my table, I've said frequency given staff. I've just kind of given that little bit of information. So out of all the staff members, if we look back up here, these are the numbers that I'm looking at here. So out of the staff members, 105 have American cars, 12 had European cars, and 47 had Asian cars. Part D says they want the marginal distribution for the driver type. So now I'm going to focus on staff and students. Whoops. Well, that's okay. Doesn't have to be in any specific order. I flipped the order, but that's okay. Staff and student. And I want to, given the condition of American manufacturer. So out of all the American cars, how many staff members had American cars? It was 105. And how many students had American cars was 107. All right, our last kind of chart that we're going to look at today is the segmented bar chart. So segmented bar chart treats each bar as a whole and divides it proportionally into segments corresponding to the percentage in each group. This is actually going to be really similar to a pie chart, except it's not going to be round. It's going to be rectangular. It's like a rectangular pie chart. Therefore, the maximum value on the vertical axis has to always be equal to 1 because we're going to get up to 100%. And we do this for when we have more than one category and we want to kind of put it all together in one graph. All right, so first we need to make sure always title our graph. And in this case, that would be origin. Well, okay. The title depends on how you want to do this, actually. So we could title it Origin of Car Manufacturer and make our horizontal axis the 3 types of car manufacturer. Or we could title it Type of Driver and make our horizontal axis type of driver. And then the other category is going to come into play with how we like shade or color it. So I'm just going to go with origin of car manufacturer. Sorry, my pen is lagging here. Which means I'm going to have American, I'm going to have European, and I'm going to have Asian cars. And I'm not just going to start I'm missing something. This came out of a contingency table with two different categories. Over here on my vertical axis, I do need to title this relative frequency because I have them in percentages or decimals, proportions. And then I'm going to make two kind of labels over here. One of the labels is going to be shaded, and this one's going to represent students. And here I'm going to represent staff with the shaded portion. So for each one of these, you can actually start by just drawing your rectangles. They're all going to be exactly the same. They're all going to go up to 100% or 1.0. Try to make them relatively the same width, like that. And then we kind of break up each one in terms of how many students and how many staff there were. So if we look at the American cars, so let's just look at part D here. Given that we had American cars, I had 105 staff members and 107 students. So it was a little bit more than half students than staff. So I can draw a little bit more than half. I can break that apart and then shade this piece for the staff member piece, and the unshaded part of that is for the students. Given that we had European cars, now let's go back up to our table. Given that we had European cars, I had 33 students and 12 staff members. So 33, and I can just kind of do this on the side, 33 out of 45, and get my handy dandy calculator here. 33 divided by 45 is 0.73. So it's almost 3/4 is going to be student. Little less than 3/4. Oops, come on. There we go. It's going to be student, and then staff is up here. And then same thing with Asian cars. So if we go back up to the table, we had 55 out of 102. So 55 divided by 102 is 54%. So a little more than half was students, 54%. So I don't know, somewhere like right there or so. And the rest was staff. All right, and that's what a segmented bar chart looks like. So again, we could have decided to take these categories and these categories, and we could have, we could have switched them for an option. So there's nothing saying that we had to put the car manufacturers on the horizontal axis and do two labels for student and staff. We could have put student and staff on the horizontal axis and done 3 labels for each one of the cars. So it just depends on, if it doesn't specify, you can kind of just decide which way you want to do it. All right, and then the last little piece here, we're just going to talk about misleading displays. The area principle demands that the area occupied by a part of the graph must correspond to the magnitude of the value it represents. So I know that some of these graphs look fancy and they look fun and nice to look at, but these are really bad graphs. The first one here, if you notice like this part here versus this part here, because it's at some weird angle, it's hard to tell. It looks like the purple one is a little lower than the other one, but because it's like farther back from, our point of view, it looks a lot smaller. The area of that purple piece is going to be way smaller than the area of the yellow piece, even though I think they're supposed to be relatively close. Same with the Halloween candy collected. If you notice, this goes up to 18 and this goes up to 36, which means this should just be twice as much, but that is more than 2 of those little candy corns. I can fit more than 2 little candy corns into the big one. So the area doesn't correspond to the difference between the magnitudes. All right, same with the trash cans. Here's like a really nice image. This one is bad. because the first little guy is at 1, the third guy or the second guy B is at 3, but he's like way more than 3 times as big as the first one. You can see why that's bad here. You can fit 9 of the little ones in the big one, even though it's just supposed to be 3. This one is a good representation. So that one is definitely 3 times more than A. All right, and that concludes our lesson.